Okay, so here's a video going over lesson 37. The topic is linear quadratic systems. I wanted to start off with the notes, just in case you missed them in class, or to refresh you what the point of all this is. Now, a system of equations, the word system, implies that there are two or more equations on the same graph. Now, the solution, when we're trying to find the solution to a system, that's the intersection point or intersection points to all those equations. Intersection points are values of x comma y, so that's what your answer should look like. They should look like points, x comma y. So intersection points are values of x comma y that when substituted, meaning plugged in, it makes all the equations true. Now, a linear quadratic system. A linear quadratic system has three possibilities. A linear quadratic system can have 2 points of intersection, which also, by the way, means two algebraic solutions as well. It can have 1 point of intersection. All right, so remember that this is the quadratic. The quadratic is U-shaped. And the linear is a straight line. So they can intersect at 1 point, and that also means that there's one solution when we solve it algebraically. We can have 0 points, which means that our solutions are imaginary. And we don't need to get so heavy into that because we're going to get into imaginary a little heavier later on in the course. But it means that our solutions are imaginary. Now, in order to solve these systems, when you're given the equations, you're given the functions, what we have to do is a very quick 4 steps. Now, there's a lot of algebra going on in between these steps, but that's Algebra 1 work, and that's nothing new. The new stuff is just this 4-step system. What you're going to do is you're going to isolate a variable, like x or y, in the linear function. You're going to substitute into the quadratic. You're going to solve for one variable, and you'll plug back in to solve for the other. So let's pick a question, and I'll refer back to these steps as we go through it. Let's do question number 9. Now remember, this is linear quadratic. This is the linear one because it's a linear function. There are no exponents. And this is a quadratic because it has squares on the x's and the y's. Okay, if there's a square, it's a quadratic. So let's take these over to our other page. I'll just rewrite it so I can copy it over. We have x squared plus y squared equals 5. And x plus y equals 3. That's question number 9. Clear up a little more space here to finish the question. Make sure I don't run out. Okay. So question number 9. Here are 2 equations. Since we have 2, it's a system. Now, step 1 is isolate a variable in the linear function. Isolate it, meaning get it by itself. So let's say I'm going to do this. I'll pick x. So if I subtract y on both sides to get the y away from the x is now isolated. X is equal to 3 minus y. X is isolated, it's all by itself. What is it equal to? X is equal to this. So what I'm saying is x is equal to 3 minus y. Variable isolated. Now we're going to substitute into the quadratic. What that means is, you see this x here. Well, x is equal to 3 minus y. So since they're equal, I can plug this in parentheses in the place where the y was. So when I rewrite this, I'm going to get, instead of x squared, what is x equal to? It's equal to 3 minus y. And that's a substitution. You just plug it in. Now, if you didn't get that or that doesn't make any sense, back up, watch through it again, and see if you can figure it out. Now, if you know what you're doing from this point, you can follow the 4 steps. Just pause the video and finish it yourself. Okay. What we're going to do is we're going to expand it. We want to solve for y, but here's the problem. I have a y here, and I have a y here. Well, I can't combine those yet, but what I can do is I can expand, then combine like terms. So when I expand, what I mean is I'm going to take 3 minus y squared, and I'm going to turn it into 3 minus y times 3 minus y, because that's what a square means. Bring down everything else. 3 minus y times 3 minus y, that's a binomial times a binomial, and that means we're going to need a box method. 3 minus y and 3 minus y. Y times negative 3, or 3 times negative y is going to be negative 3y. Bottom right, negative times negative is positive. Y times y is y squared. 3 times 3 is 9. And 3 times negative y is negative 3y. Now let's take these terms out. Doesn't really matter in what order. 9 minus 3y minus 3y plus y squared. Bring this down. Plus y squared is equal to 5. Now let's combine some like terms. Y squared and y squared are like terms. When I add those up, I'm going to get 2y squared. Negative 3y and negative 3y are like. That gets me negative 6y. The 9 all stands by himself, so I'm going to put that plus 9 at the end. That's equal to 5. Now this is looking pretty good, but it looks like a quadratic, meaning it needs to be equal to 0. So I'm going to have to subtract 5 from both sides. I get 2y squared minus 6y plus 4 equals 0. This is a quadratic, and what we're going to be doing is we're going to be finding the roots. Now how can I simplify this? How can I factor this? I've got options. I could A, B, and C, and I could factor by grouping. But you might have noticed an even better thing. These are all divisible by 2. So we're just simplifying now. Y squared minus 3y plus 2 equals 0. And since there's no number on the front, or rather that number on the front is a 1, we're allowed to just use add and multiply factoring. Double bubble. So two numbers that'll multiply to give me 2. 2 times 1, or negative 2 times negative 1. Those are the only two things that'll get me 2. So if I take the negative 2 and negative 1, because those once again will add to 3, I get y minus 2 and y minus 1 equal to 0. Alright, minus 2, minus 1. If you don't know where these came from, because you're a little rusty on this, I'll just do a little scratch work and then erase it. Y minus 2 times y minus 1. If I wanted to multiply these back to prove to you that it is this is negative 2y, y squared, negative 1y, and positive 2. When you bring these out, y squared minus 3y plus 2. Hey, wait, that's exactly what we started with. Okay, so that was a little proof that my factoring was equal to what it started as, that this and this are actually equal, and I wasn't just making that up. But now how do I solve something that looks like this? What I have to do is I have to t-chart it. Y is going to be equal to 2, and y is going to be equal to 1. And if you're not sure why, it's because y minus 1, set it equal to 0. Find y by adding the 1 over. Y equals 1. Okay, so y is equal to 1 and y is equal to 2. That seems really nice and easy. Let's see how many steps we've done so far. Found y. So I've substituted. I've solved for one variable. I got the y's. But now I have to plug back in and solve for the other variable. So I have to find x now. I'm going to pick the easiest equation in the entire question. So let's see what that is. What's the easiest equation? This one. X plus y equals 3. So I will start with the original. When y equals 2, I have x plus y equals 3, meaning that x plus 2 equals 3, minus 2 minus 2, and x equals 1. So that means one of my points of intersection is x comma y, which is 1 comma 2. That's one of the intersection points. The other one, when y equals 1, we have the equation x plus y equals 3. X plus 1 equals 3. Minus 1 minus 1. And x equals 2. So my other point is going to be 2 comma 1. Those are the two intersection points between these two equations, these two functions. If I graph them, you could see that those 2 points are the points at which they hit. Okay, so make sure you follow all the steps. If you need any help, I'm here for office hours like always, and good luck with your 3 questions for homework.